I first of all thanks the organizer for having me here and thinking about me for this session. So before I go into what I want to present, I want to say a few things about today's presentation. We saw a couple of them, and this is also a vector-borne disease which I will be talking about. So Olivia presented, then Folu presented, and then Maya presented. So this model is also very much similar to that, and it's a joint work with Dr. Christopher Kristoleta. He's at University of Texas, Arlington. And what we are looking at, how the competitions are getting affected in the Texas region in United States for, and the parasite we are concerned with is Trypanosoma cruzi, and we are looking at sylvatic host. Sylvatic is the wild host, basically, and that's our focus. These pictures shows this is kind of a neglected disease, as you guys were discussing about malaria and other diseases vector-borne. This is also one of the very neglected disease. And the big problem is it's not very symptomatic, and so people know it at very last stage. Okay, by the way, Trypanosoma cruzi is not the disease, it's a parasite name. So let me go to this slide, which will describe you what we are talking about. So the disease is called as Chagas disease, which is caused by Trypanosoma cruzi, T. cruzi. And let's see if this will work or this will not work. The laser will work, right? Okay. So the T. cruzi, Trypanosoma cruzi, is a parasite which is responsible for the Chagas disease. And what happens is it is not symptomatic disease. And what happens is you get to know at a very late stage, and people die because of cardiac arrest because it spoils, it deteriorates your heart, basically. And it is again a vector-borne disease. That means there is insects, bugs, which is triatomine bugs, which the biting of that bugs causes this parasite to spread between the host. Most humans are not the very common host, but different hosts like wild animals and sylvatic animals. And our focus today would be actually wild. So in US, there's only a handful of cases which are documented of this disease, this particular disease. But there is high prevalence in the wild hosts like raccoons, possums, wood rats in the south and southeast states of US. Mathematical models have focused on humans, and there has recently been, by Dr. Christopher Kristoleta and his group, has seen some studies recently on sylvatic host. And this is one of the work in extension to those. So the global prevalence, it's not everywhere. As you can see, it's America, some part of Australia, Europe also. Most common endemic, in fact it is endemic in Latin America, this whole area. Mexico is also very high. The darker the region, the higher the prevalence is. And mostly in rural and the areas which are near the forest edge, basically, where these bugs are found, and the bugs encroach the domestic area, and therefore this cycle continues. You can prevent it, but one thing to prevent is reduce the number of bitings in the domestic host. So roughly around 14,000 deaths every year. So this is quite long. This is reported, approximated one, and basically no one has an idea how many deaths happens, but this is something which people agree with, that this would be the case. Around 10 to 15 million people suffer from this disease, and 25% of this whole population is are at risk. So let me give you a life cycle of this parasite, how this parasite spreads. So this is a bug, and I'll show you the pictures exactly. So bugs become infected after biting the infected host. So this is a susceptible vector or susceptible bug. It's biting and it's sucking the blood, and therefore parasites in it. And this is a host here. And hosts get infected when they unknowingly rub the bug feces into the bite wound. So that means it's a very tricky process here how this infection gets spread. The bug bites, and at almost roughly around the same time, it defecates right there. And a person rubs it, and that's how it goes in the wound, basically. And we are talking about very, very minute, very, very microscopic parasites. So you can't really see it. But the process, this is what the biting occurs. It is not by the bite that the parasite goes inside, but by the defecation of the bugs right next to the exit, to the bite wound, that these parasite enters. So, okay, so let me talk about actually, I should have said instead of, this is the players in T. cruzi spread, not Chagas disease, but Trypanosoma cruzi spread. That's what I mean. That's the difference in saying the disease is spread and the parasite is spread. Because there are strains of this parasite which does not cause the Chagas disease. So only the certain strain causes the Chagas disease. So we are talking about players of this parasite spread, and they are hosts, mostly mammals, humans and animals. Common ones are very common in sylvatic hosts like raccoons, possum, and wood rats. Sylvatic means wild as opposed to domestic. And vectors are blood-sucking assassin or kissing bugs. That's the common name people use it. But the scientific name is Trypanosoma bugs. Parasites, Trypanosoma cruzi, and that is what we are talking about here. Environmental, social factors influence their spread. And you can see that there are many different cycles, one happening in the domestic animals and around the domestic regions, one in the sylvatic wild animals, and there are so many cycles, and one at the intersection of domestic and wild, basically. So there are different types of cycle, different types of species, different types of hosts which can host this parasite. So these are the bugs. The most common in US, these are the Trypanosoma species, and these are in the US they are Trypanosoma gristecri and Trypanosoma sanguisuga, the two common ones. These are the two common ones which are found. Whereas in US, the sylvatic host which are common is raccoons and wood rats. Okay, so I'm going very fast. There are 6 strains that have been identified for this parasite. Not all causes Chagas disease, as I said earlier. The one which is present in US is less virulent and therefore doesn't cause the Chagas disease as compared to one in the Latin America. So, but still we see cases in US because of the migration of people here, and also sometimes vectors. Because Mexico is also considered as an endemic region. Infection with one strain appears to provide cross immunity with others. That means in US, if a person gets infected with the local strain, the one which is bad, which is coming from Latin America or which is highly virulent, it is difficult for a person to get that infection once you are infected with the local strain. So it does the cross immunity in that respect. There are 2 types of strain. I mean, among these 6, there are 2 types of strains, strain 1 and 4. These are the categorization they have, scientists have given it. In US, that are common in US, and one that causes clinical system and other does not. The strain 1, which is the Latin American strain, is slowly found in some region of Texas. This strain causes clinical symptoms, whereas this does not cause clinical symptom. And this is basically, you are infected with parasite, you will have light symptoms, but you will not have a full-blown Chagas disease at any point of time. Now there are different modes of transmission by which these parasites, these different strains are transmitted. T. cruzi 4, strain 4, is more adapted to vertical transmission. What is vertical transmission? That means we are saying from mother to child. during the birth. So basically these are mammals we are talking about. So vertical transmission in the host, not in the vector, in the host. Both strain 1 and 4 are present in wood rat population. So wood rat is another population which is common. With wood rat host is common in US, and both the strains are present in that population. So just to give you a broad outline of this, we are talking about 2 vector species, we are talking about 2 hosts, and we are talking about 2 strains. There are 2 things, 2. And the regions which are affected is this region. So this 1, 2, and 3, and this tells you patch 1, patch 2, and patch 3. And you can see this, the one, they occur in the cycle actually. So for example, gustectory and T. gustectory and wood rats go together. That means the cycle is maintained by this species of the vector with this host. And the other one, raccoons and sanguisuga, is another cycle that maintains the infection. And there is a crossover also. So I'll come back to the slide in 1 minute. You see, strain 1 and 4 are present in both the host, in the wood rat population. These 2 strains are found in both in the host, in the wood rat host. So in this cycle, both strains are found, 1 and 2. Whereas in this cycle, only strain 4 is common. So what happens is in the patch 2, in this region, these 2 cycles kind of come together. And therefore and this is more virulent. The strain 1, which is common here, is more virulent. It more causes the Chagas disease. Latin America causes more Chagas disease. Here there is no Chagas disease because the strain is not that much virulent. So, and they interplay in this patch 2, which is an important region because these 2 cycles play its very important role. And that's how the infection gets transmitted from one cycle to another. So our research goal is to describe the sylvatic transmission dynamics for evaluating the competition between the 2 parasite strains that I'm talking about in US. How we evaluate the competition. Is it possible? Remember, the Latin America strain, as we are talking about, it is more virulent. What our concern with is that possible for the strain which is invading in the US from Latin America, is it possible for them to establish here in the US? US species of host and vector. So that's what the overall idea is here. Okay, this doesn't work. So let's first talk about few things, how these things are spread. As I said, one way for it to get spread is through the bite of the vector. But there are other transmission modes by which this parasite can be spread. The other is consume these hosts. We are talking about wild animals. They eat bugs sometimes. And when they eat it, there is likeliness that if they eat infected vectors, that the parasite can go in these hosts. So we are talking about oral transmission mode also. And then the third one is the vertical transmission in the host. So these are the 3 different ways that one can get infected. In vectors, the infection rates varies quite a lot between the species, and usually less than 5%, which has been found in the domestic vector species. And there are different reasons for infection rate to be different in the different part of the world. For example, infection rate itself and time between biting and defecation, alternative modes like these modes which we are talking about and their capability and other features of infecting strains. So this is the model. I think that is what we are concerned with. This model is a very simple model, SI type model, but incorporates the features we see in the different types of cycle present in US. So SI type model, susceptible, this is host, this is vectors, susceptible host, and this is infected host, susceptible vector and infected host. So is SI type vector-borne model. We are assuming two strains in each, two strain here, strain 1 and strain 2, and we are also assuming logistic birth rate. BH is the logistic birth rate, BV is also logistic, and the linear per capita death rate. So it's a very simple SI type model. The complication arises when we incorporate these different types of transmission modes. We have 3 different types of transmission mode, and one, so as I said earlier, Trypanosoma Cruzi 4, which is the strain 2 we are saying, is more adapted to vertical transmission. So this strain is more commonly transmitted through vertical transmission. So what we incorporated here, so we have 2 strains, 1 host, and 1 vector species. Remember, we talked about 2 different cycles, and then we have 2 cycles. So this model, if you think of this model at one place, another model, similar model on this side, one for woodrat custecary, one for raccoon and sanguisuga. So there are 2 cycles we are talking about, and each one has its own similar type of model. The difference is between these 2 cycles, the difference is in the transmission mode. So these red circles denote vertical transmission basically, and the C1 and C2 are the horizontal transmission rate, which incorporate 2 modes of transmission. One is vector feeding, VF stands for vector feeding, and the second is oral consumption, OC. That means host eating the vector. And there are 3 contact rates, which is C1, C2. These are the contact rates also, and oral consumptions, which is here, follow us. So we assume that it is a function of host to vector population, and that is keep on changing in this model. And the way we assumed it is a Holling type 1 functions, and that differs from cycle to cycle. Which cycle we are talking about, it differs from whether we are in this cycle or that cycle, because the density of raccoons and density of wood rats differ in those areas. So more details can be found in this paper, which is published in Journal of Biological Dynamics. Okay, so we heard about reproduction number and quite a lot, so I'll just go over it very fast, like 5 minutes. So R0 is very important quantities in epidemiological models, and in this vector-borne model, it's actually a geometric means of the infection generated by one infected vector times the average number of new infection generated by one infected humans, and it's an average of these 2 quantities in it's a geometric mean basically. And so in this case we have to define 2 different types of reproduction number. One we already seen in the previous talks. One is basic reproduction number, where the other strain is 0, and then how many that's a basic in a completely susceptible population. The basic reproduction number is always in a completely susceptible population, whereas invasion reproduction number is when the other strain is endemic. That's how we compute it. So we are talking about, we set one strain to be at endemic state and then compute the invasion reproduction, and it turns out to be these things. And so in the absence of vertical transmission, it is a geometric mean. But if you include the vertical transmission, it becomes this P1 and P2 are actually the vertical transmission parameter here. And if we take P1, P2 equal to 0, then what we get is the square root of this quantity, and that is just basically average number of new cases by vectors times average cases of new cases by humans. And the overall Cruzi reproduction number is the maximum of R1 and R2. So these are the R1 and R2 basic reproduction numbers for strain 1 and strain 2. The maximum of that is an overall reproduction number for this thing. Okay, so the local stability, you can, there are 3 types of equilibrium, and you can see that this type of bifurcation you will get in the basic reproduction number for strain 1 and strain 2. This is stable when both are less than 1, greater than 1, and this is invasion reproduction number, and this is basic reproduction number. E1 will be E1 as in which strain 1 is endemic, in E2 is in which strain 2 is endemic. So there are 3 possible, this is a competitive exclusion type of results which Maya presented a few minutes ago. And it is easy to see from there. We can also do certain global stability, of course, using a Lipnoff functions for, this is less than 1, sorry, this is a typo here. This is globally stable, and for greater than 1, you can, under certain conditions, assuming that the strain has the same vertical transmission, we can prove that the strain when the strain 1 persists, that is globally asymptotically stable. When strain 2 persists, that is also globally asymptotically stable. So, and actually we can do different types of analysis. One analysis would be on a reproduction number, and when these 2 numbers are good, then the strain, whichever number is greater than 1, then that strain will be endemic. And so coexistence is not possible in this thing. And the reason for that is, if this one invasion reproduction number is bigger than 1, the other one would be less than 1. And therefore you cannot have both of them to coexist, both the strain. So what we did is, we have more results, but in that paper, if you want to look into it, you can. But the idea is to describe the transmission dynamics where the competitive exclusion is important, is the phenomena there, and how do you measure those, which strain will persist over a long time in the US population, given these 2 different cycles are interacting with each other. We have done some estimations in this and some values of different parameters, and competitive exclusion is mainly decided based on vertical feeding and vertical transmission. These are the 2 important factors which describe the competition between the strain. OC doesn't play its role, but it's actually OC's oral consumption favors the vertical transmission in both the cycle. And what we found is, in raccoons, strain 2 should be more adapted to vertical transmission and oral consumption in order for it to win. Strain 2 is weaker in vertical transmission, vector feeding. Estimates in the wood rat cycle, strain 1 wins the competition, but at certain stage, strain 2 could also make it, but it needs a very high rates of vertical transmission and oral consumption. With that, I would stop and thank you for your time.